All right, so once again today we will be working off a worksheet that you have access to from the website. So I suggest you open that document on the website, and then we will work through this worksheet together to try and sort of solidify your understanding from the note lecture from last class, as well as what we did the class before and the class before that. Okay, so once you have that document open, let's read through it together. Okay, so it says, if you know the magnitude and direction of an object's velocity, can you determine the horizontal and vertical component of the vector? Well, so if we know the magnitude and direction, so they give us, let's say, 10 kilometers per hour at 24 degrees, we should be able to break it down horizontally and vertically because we know that I'm going to zoom in a little bit, the horizontal is simply equal to the sine of that times the velocity. And then we also know that the vertical velocity is equal to, oh, sorry, no, that's, I have it backwards. The vertical velocity is equal to sine theta times the original velocity, and the horizontal is equal to cosine theta times velocity that is given to you. Right? Awesome. Then question 2 says, what is the definition of the range of a projectile? Well, range meaning distance, right? How far will it cover? So it's the horizontal distance that it travels, that it will travel. Okay, so any range of projectile, it refers to how far will that projectile travel once it gets shot out of the cannon of your arm, whatever the case may be. Or in my case, the cannon is my arm. All right, and question 3. A human cannonball is propelled at a velocity of 25 meters per second. If the cannon forms an angle of 40 degrees with respect, oops, I want to move this thing. With respect to the horizon, I'm just going to leave that there. With respect to the horizon, how long will the flight of the human cannonball take if he falls back down to the same level from which he is propelled? So let's draw a quick example here. So here's the level. Here's the ground. So the person is shot from here. Boom. Boom. And lands at the same spot. So if that was the case, and we know that it is 40 degrees here at 25 meters per second, they want to know the time. How long will it take for the human cannonball to land back down on the other side? So let's look at the vertical component first. We know that the vertical velocity is equal to sine of 40 times 25, which gives us a value of 16.1, so meters per second. And then we know that gravity always pulls at negative, so acceleration is a negative 9.8 meters per second squared. And so with those two pieces of information, we can calculate time. So from V2 equals V1 plus AT, right? So therefore we plug in our A, plug in our T, and we get V2 is 0, because at the very top there's no vertical velocity. So we get our T is equal to, plug in all the numbers, and 1.15, something like that. No, 1.65. I don't have my calculator with me. V1 plus 1/2 AT squared v2 equals v1 plus 1 half at squared. So if we double that, we should get an answer of, so because it's going up and coming down, we should get an answer of 3.29 seconds. Or 3.3. 3.3. Okay. Alrighty. So we're going through section 1. Or worksheet 11.3 together, just like we did for 11.1, I believe, so that we see if you get a clear understanding of what we did last class and class before that and all that stuff. So open the document and then we will go through it together. If you know the magnitude and direction of an object's velocity vector, can you determine the horizontal and vertical? Of course you can. We just did that last class. If we know, I'm going to zoom in a little bit. So if we know the velocity, we can calculate the vertical component is equal to the sine of the angle times the velocity. And therefore, the horizontal part is equal to the cos of the theta times the velocity. All right? That you should have memorized. And then question 2 says, what is the definition of the range of the projectile? Well, range means how the distance covered. So how far the projectile will travel. Will travel horizontally. All right. Now, so a human cannonball is propelled at a velocity of 25 meters per second. So that is the velocity at an angle of 40. So our first step is we have to calculate the vertical velocity, which is equal to the sine of 40 times 25, which gives us a vertical velocity of 16.1 meters per second. And then we know that acceleration is going to be negative 9.8 meters per second squared. And we know that the final velocity, v2, is equal to 0 meters per second because it is going up and back down. So we know this initial one, we know the top here, v2 is equal to 0. So it has to be that way. And then we can use our equations that we know. We know that v2 is equal to v1 plus at, which means that we have 0 is equal to 16.1 plus negative 9.81 meters per second squared times t, and we get t is equal to 1.65 seconds. Now remember, that's only halfway to there, so we need to double it, so times 2, and we get 3.3 seconds for the entire flight, or I rounded off somewhere in there. All right, so now we go on to part B. Says if the cannon forms 40 degrees to the horizon, which is the same as part A, what will be the maximum height reached by the cannonball? Okay, so to answer this one, we need to do a second equation. So we have initial velocity is still 16.1 meters per second. Acceleration is still negative 9.8 meters per second. And we know that the time needed to get to the top is 1.65. So now we need to go v2 squared equals v1 squared plus 2ad, right? So now we have the final velocity is equal to the initial velocity plus 2ad. So final velocity we know is 0 because at the very top there is no vertical velocity. We know that the initial velocity is still 16.1 squared, and then we know that 2 and then negative 9.8, and we have D, which is what we're looking for. What is the horizontal distance? So if we do all the calculation there, you should get an answer of 13.2 meters, with rounding a little bit here and there. Okie dokie. All right, so now part C said, what is the minimum angle between the ground and the cannon if the man wants to fly over a 50-meter wall height? So that's slightly different. Now we have a wall in the middle that is 15 meters. The cannon's still here, the person's still here, and now they're doing that. Okay, so we still know the initial velocity is 25 meters per second, but we don't know the angle at which it is being shot out at. But if we know the height that we want to clear, we can simply use this equation to solve for it. So we first need to figure out, okay, so we know that the V2 squared is equal to V1 squared plus 2a delta D. Now V2 we know is 0 squared is equal to V1. Well, what is the vertical height? What is the vertical velocity? Well, the vertical velocity is still equal to 25 sine of the unknown angle plus 2 negative 9.8 15, right? So we know it has to clear 15, so therefore we plug that into a calculator and do the math, a little bit inverse sine, we should end up with an answer of 43.3 degrees. Okay, so hopefully this clears up a little bit some of the understanding that we've been trying to get for the last couple of lessons. If do the math, do the calculations, do all the fine work that I didn't do here, and then if you have any issues, just send me an email. Okie dokie. See you next time.